Okay, so today, guys, what we're going to do is we're going to go straight to the MCAT problems to talk about this one because it's very straightforward, but they're always there, right? And they're also the key to making some other things work. Now, you may or may not remember what rational expressions means. Rational expressions just means those big fractions. Anytime you see the word rational, that means a fraction. And an expression means that it's not an equation. There you go. So these are just big fractions, and we need to work with them. Now remember, we talked about and worked out rules for working with fractions when we were doing the numbers. So you're still gonna. The good news is you still use the same processes. The bad news is there's one other step. And the second piece of bad news is that most people still don't know how to do fractions by hand. So not in this class because you are all geniuses. But make sure you are really focusing on being able to do these fractions by hand. Okay? Now, so we're just going to run through some of them and talk you through the steps. Now, I'm not going to rewrite all the steps for simplifying a fraction and adding fractions and subtracting fractions because you've got notes for those. That never changes. But what does change with rational expressions is that there's a further step that you need to add first. And the first step for solving any rational expression is to factor completely. And remember, I always call it completely because I'm hoping that reminds you that to always look for the what first? GCF, the greatest common factor, or HCF, whichever one you want to call it, right? So you're going to factor them. Because if you'll remember when you're simplifying, we divide out common factors that are common to both numerator and denominator. And the only way you can use division to remove something is if it's connected with what? What's the opposite of division? Multiplication. Okay? So you've got to be very, very careful, okay? That you cannot simplify anything or you cannot remove anything with division unless it's connected with multiplication. And the way to make that work is you first factor completely. So we're going to go through a few of these. And again, these are coming straight from past MCAT assessments so that you can know that you're looking at things that you're like the ones you're going to see. Okay? I will tell you that they think this is pretty low-level math, and so most of these are just achieved. But they can build some stuff with these that are merit and excellence. Okay? Because if you use this, part of it will be this, and then it'll build on. All right? So we're just going to look at some of these. This is in the factorizing part of the problems. So some of you have probably done some of these already, but maybe not. We'll see. Okay, just one moment. Record that. So to factor completely, build the LCD from those factors, start with the biggest denominator, bring in any factors from the other denominators that aren't already there. So here we put in our biggest denominator. That x minus 1 was already there, so we didn't need another one. Again, if you make it too big, you're going to have problems. Okay? And remember, the LCD is important because we need it when we add rational expressions. We need it when we subtract rational expressions. And when else do you use an LCD? To clear the fractions from an equation. Remember that? So you're going to need LCD a lot. Now, do you need an LCD when you multiply? Nope. Do you need it when you divide? No. But you do for the adding and subtracting. Okay? So keep that in mind as we go. Let's just look at this one. So here we go. We have our problem. Excuse me. So it's 3 over 3x minus 1. I'm just writing it because I'm going to change it to notebook paper in a minute. Minus 2 over 2x plus 1. Okay. So we're subtracting fractions. And actually, these are rational expressions because they're not, it's because they have x's, unknowns in them. So I need to find the LCD. Now, I don't have anything to factor because these won't factor. If they don't factor, I like to hold them together with a bracket just so that you know that that's a 3x minus 1, not a 3x and a negative 1. It's one thing. Another thing about it is if you have subtraction, if there's a minus in front of a fraction, we talked about this when we did by hand, I'm going to move that minus into the numerator. Because the math that I'm going to do is going to be in the numerator. Once I build the LCD, it's going to stay the same. Right? So be careful about that. What if I'd had like 2x minus 1 in the numerator? When I move that minus into the numerator, what's it going to do?
Negative 2x plus 1.
There you go. It's going to change both signs. You must distribute it through the entire numerator. Okay? Sound familiar? I hope. Not. Don't worry about it. We're going to practice. Okay. So we're going to build our LCD first. So we got 3x minus 1 for my first one. The next one is 2x plus 1. Is there already a 2x plus 1 down there? Nope. So I need a 2x plus 1. In this case, I'm literally building, I need both factors from both denominators. If we change the denominator, what else must we change? The numerator. And remember I taught you that divide then multiply pattern? Let me just remind you of it. We're going to take the LCD divided by the old denominator, and then we're going to take that quotient. Quotient means the answer when you divide. Yes, I'm going to use math words because I want you to get used to them. Times the numerator. Now, with these, it's easy to see what's going to divide away. Anything that's the same will just divide away, and you multiply by what's left, yeah? So what's the same in my original denominator here and my LCD down here? 3x minus 1. Okay? So if you ignore the 3x minus 1, what does that leave you down here in the bottom?
2x plus 1.
So the multiplier for the first one is 2x plus 1. Right? This was already in that fraction. I need to put this in that fraction now. Okay? So I took this thing divided by that thing, and whatever's left, which was here, times the numerator. Go back and practice if you want to. I'm going to give you an assignment on this too, so you can practice some of these. So let's multiply. What's 3 times 2x?
6x.
What's 3 times positive 1?
3.
Okay, positive 3, yeah. Be careful with your signs there. All right, now let's do the second one. What's the same in my original denominator and my new denominator? 2x plus 1. So that means I'm going to multiply the negative 2 by the other factor of 3x minus 1. Let's multiply. Negative 2 times 3x is negative 6x. Negative 2 times negative 1 is positive 2. And then it should be painfully obvious to do what's next? What? Just combine any like terms in the numerator, right? Simplify the numerator. What's going to happen to 6x's minus 6x's? They subtract away, make 0. So what's left is positive 3 plus 2, which is 5. And it's all still over 3x minus 1 times 2x plus 1. Again, there's a lot of work involved in these, but it's not difficult work. Your job is to remember when to do what. Okay? So that's our final answer. Have it written down so we can check it to make sure I did it right. Okay? So, checking it. There we go. Right there. 5 over 3x minus 1, 2x plus 1. And look at that! Merritt. There is no way, if they keep doing these, that you could get as an achieved. Hold on just one moment, please. Simplify. What does that mean to do first?
You have to put my lowest
Factor completely. Just remember, if you see one of these rational expressions, the first thing you should do is start factorizing, right? Okay. Looking at the top, is there anything common to 17, xy, and so 17, 14, and 1 don't have anything in common. Is there an x in all of them? Yes. So we have a common factor of x. Is there a y in all of them? Yes. So we have a common factor of y. So we'll start there. 17xy squared. Divide out xy, you get 17y. Right? The x is divided away. Y squared divided by y. Minus 14. X to the third divided by x is x squared. Y divided by y is nothing. 1. It makes a 1, so they're gone.
Y?
Okay. Plus, now the x's are going to divide out of that one, and y squared divided by y is y. Okay? I'm factoring out a common factor.
It's y. I just like no.
I know. I mean, the first time you see something like this, it's weird. All right. So we have A equals this junk and B equals this junk, right? Give an expression for A in terms of B. So let me translate it for you. That means we want it to say A equals B blah 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 something. So A equals B something. Not exactly. Not exactly. What we're going to do is we're going to clean them. So what we're going to do is we're going to clean them both up, and I'm going to see what's the difference between A and B. Right? And then whatever the difference is, that's what I need to put in. Hold on. Let me just show you. Come on. Shh. Let me show you. So we have 3 times n squared minus 4n. It's easier on notebook paper. That's why I'm just rewriting it. Plus n. That's our A. Our B is 2n plus 1 times n minus 6 plus n squared plus 3. Okay. So what we want to do is, I just want to simplify these as much as possible. So because in order to find out if one of them is the same, because they could be equal. A could be equal to B, couldn't it be? But I need to find out. Okay? But I can't find out in this form. I have to clean it all up. So let's first of all, we have this bracket to multiply out. There's no like terms inside. There is no exponent. But there is a multiplier, or a coefficient it's called. So I need to distribute that 3 all the way across. So 3 times n squared is 3n squared. 3 times negative 4 is negative 12n. 3 times positive 2 is positive 6. And then we have that plus n at the end. Now, what's left? Combine like terms. Right? So that's going to give me 3n squared minus 11n's plus 6. So there's A all cleaned up. So if you have brackets to start with, expand them to clean it up. If you don't have brackets, factorize it to get some. It's just an insane system, but that's just pretty much the way it works. Now here. Well, not yet. Yeah, right now what we're doing is expanding and simplifying. There you go. So now let's do this one. 2n times an n is 2n squared. I'm multiplying at the bottom. 2n times n, right? 2n times negative 6 is negative 12n. So you see some stuff starting to match. Okay? All right. Now, positive 1 times n is positive 1n. Positive 1 times negative 6 is negative 6. And then we still have that plus n squared plus 3 at the end.
Oh my gosh.
Yes?
Wouldn't you combine like terms of there and do plus n minus 12n?
Well, we're just not finished yet. Yes. Yeah, I just brought everything down because there's a lot of like terms. 2n squared and n squared are going to make what?
What do I need up top for a?
Oh, I did.
Oh,
there we go.
Sorry.
No worries. Yeah, so I did at the end. So 3n squared.
Why isn't it 3n to the...
Because when you're combining like terms, if you keep the base and exponent and combine the coefficients. It's like having 3 oranges and 5 more oranges. You get more oranges when you combine them. Now, if you multiply them, then the exponents would change. Right?
I thought you couldn't add... If it has an exponent, you can add it like... I thought you can add
If the exponent is the same, you can.
Oh, it's the same.
Right, it's the same exponent. My handwriting is terrible, sorry. All right, negative 12n plus 1n is negative 11n. Okay, and negative 6 plus 3 is what?
3.
Negative 3. Now that we've cleaned them up, do they look similar?
Yeah.
They're not quite equal, but parts of them are, aren't they?
Yeah.
Which things are the same?
The first 3.
Okay. So all I need to do is think of how could I turn that negative 3 into a positive 6? In other words, how can I turn the B one into that one? Plus what? Plus 9. So therefore, A is the same as the B plus a 9.
Oh, that's actually not as bad as I was expecting. That's
That's a thinker. Some of you think it is a stinker, but yeah, it's not bad. So, because we have one fraction equals another fraction, that makes it a proportion. Some fraction equals another. So to clear the fractions, we'll simply cross multiply. Now, that does not always happen. Remember, you can't do that unless it's one fraction equals what? Another fraction. Now, however, think about this. Say you had like A over B equals D. That is one fraction equals another fraction because every whole number can be written as a fraction by putting it over a what? A 1. So if you have a fraction equals a number, same thing applies. It just makes your life easier if you memorize it, but you've got to remember that that's what these are. Okay? And then you can use those rules. It makes life a lot easier. So all we're going to do to clear the fractions in this is cross multiply. And when you do cross multiply, the fractions are gone. So don't be sticking them back in. All right? So we're going to take the numerator of this fraction times what? 3. So 3 times x squared plus 2x minus 15. So that's one side of the fraction. Now we're going to take this denominator times the x. So x times x plus 3 times x minus 3. Do not multiply it all out yet. Okay? Let's look at it first and see if there's anything we can do. But there's nothing that can really happen. The only thing that could happen is, like, what if I had just a plain old x on this side and a plain old x on that side? I could divide it away. Okay? Here's another little jewel I'm going to drop on you. Anytime you have exactly the same factor on both sides of an equation, they will divide each other away. Because if you divide both sides by the same thing, that thing divides away, right? Okay? It turns into a 1, right? But you don't need a 1 unless everything else is gone. All right, but that didn't happen here. So, but let's factorize this thing. Okay, so bring down your 3. Okay, x squared can only be x and x. So the two factors of negative 15 that'll combine to make positive 2. Yep, there you go. Okay, equals x times x plus 3 times x minus 3. Do you notice that there are two things that are identical? And they're on either side of the equal symbol? So they will divide each other away. So that x minus 3 is gone, and so is that one. Again, because if you had tried to set it equal to 0, right, they would have gone away anyway. Because you would have subtracted them? Well, because this is a quadratic. Okay? Either way, because it wouldn't matter. Because if you subtracted this one from that one, it would all go away anyway. Trust me. Anyway, so anytime you have the same thing on each side. Now, if you tried to subtract them, what you'd have to do is multiply out the brackets and then subtract them, and they would all be like terms and they would fall out. So on this side, I have 3 times x plus 5. On this side, I have x times x plus 3. Now, I've eliminated the fractions, but in doing so, I've added more brackets. And I can't solve it with brackets in it. So what's next? Expand the brackets. 3 times x is 3x. 3 times negative that is positive 15. X times that is x squared. X times positive 3 is positive 3x. There's 2 3x's. But they're not multiplied together.
Oh my god.
Remember, it's got to be things that are so they're going to eliminate each other anyway, though. Because if you subtract them. So up here, things that are multiplied together will divide each other away. Down here, things that are added together will what? They'll subtract away. Right? So they're gone. So that leaves me 15 equals x squared. Set it equal to 0. Gives you x squared minus 15 equals 0. No. So, you're going to have to solve this one using the quadratic formula.
Okay, if you make it this far, will they be like...
You probably get something, but you're not going to get all of it.
How is it even possible to do it with the quadratic formula? Because then you don't have an x, so then your decision is 0x.
So you don't have a b, so that means your b is 0. Right? So quadratic formula, remember, x equals opposite of b plus and minus the square root of b squared minus 4ac. We haven't done it in this class, but we're introducing it now, all over 2a. You don't need a calculator for that.
How are we supposed to do that?
The most you'll just simplify it with a radical in it. You can't do it with a calculator.
Do we need to memorize that?
I don't know if it's on your formula sheet or not.
If you say this.
Who has your book?
Yes, I will be.
It won't factorize, but you can, very sneaky, you can simplify this somewhat by unsquaring the x by taking the what? Now, they're not looking for it, but you could have it. But if you do that, you better be careful, because it doesn't give you x equals the square root of 15. It gives you x equals plus and what? And if you forget the plus and minus, you've just changed the answer. So if you're going to do that, anytime you take the square root of a number, you get a positive and a negative value when you're solving. But they're not looking for that. That was just a question that someone was thinking they might do, which is fine.
If you're taking a square root, isn't it like assumed that there's a plus and a minus?
No.
No?
You have to write it. Anytime you don't write it, you're assuming only the positive value.
Okay.
You have to write both of them. Okay? All right, guys. So I'm going to put this out there for you as an assignment. You can see that, like here, you're just going to add this fraction to see if they're the same. What are we doing here? Factorize and simplify. Okay. Area of the rectangle, so just factorize it to find a length and a width, right? And there we go. All right. Thank you, ladies.